So this lecture is on AVL trees, which is part of a binary search tree. The difference is that binary searcher and AVL tree is that AVL trees are balanced for easier access, easier search, and delete and all that stuff. So these are 4 different AVL trees that I generated. So I want to go through these trees and see which ones are balanced, and I'm going to include what is known as a balance factor. The way the balance factor works is that what you do with the balance factor is that you take the height of the left subtree, you subtract the height of the right subtree. So this is the height of the right subtree. Now, it can be done the other way around. So I could have said the height of the right subtree minus the height of the left subtree. Doesn't matter. Now, when I do this, so the balance factor is definitely has to be the difference between the left subtree in this case and the right subtree. I'm going to get a value. Has to be within 0, has to be -1, 0, and 1. Any other value that I get means that this tree is not balanced. So let's look at this. I'm going to start with this node here. These are the roots. So this is a root, that's a leaf, that's a subtree. Now this has a left node tree and a right node subtree. So if I do 0.0, that gives me a 0. Now here I have a 1, and then there is a 0 right subtree. So this would be 1, the depth minus 0, so that's a 1. See that? If I look at this one, 0 subtree, a left subtree, 0 right subtree, so that's a 0. Now this one here is also 1 left subtree, 0 right subtree, so it would be 1 minus 0, which is 1. Now if I look at this part here, I have 2, the depth here is 2 left subtree and also 2 left subtree, will be 2 minus 2, that's a 0, see the depth. So now, according to this tree, the balance factor is between 0 and 1, so that means this is a balanced tree. So definitely it's a balanced binary search tree, so it's known as an AVL tree. So it is balanced. Now let's look at this one, the second one. That's the root, leaf, leaf. So this is the leaf, so left subtree, right subtree is null, so that's a 0. So if I do 0 minus 0 is 0. The left subtree of this node here is 1, the right subtree is 0, so there are no right subtree, so left, which is 1 minus 0, that's a 0. Now this node here, which is the root of this subtree, has 2 left subtree, the depth is 2, but there's 0, so 2 minus 1 is 2, so 2 minus 1 is 2. Now if I look at this one, 0 left subtree, 0 right 3, that's a 0. If I look at the root here, it's 1 minus, I have 1, 2, 3, the depth is 3. So this would be 1 minus 3, which is, I get a -2. So definitely this is not balanced. Why is it not balanced? Because I have a balance factor of 2 and -2. So that's what makes it, that's what makes this AVL tree not a balanced tree. Let's look at this one. This here gives me left subtree is 0, right subtree is 0, so that's a 0. So 0 minus 0 is 0. Left subtree is 1, right subtree is 0. 1 minus 0 is 1. Okay, so that's a 1. Now this again, left subtree, they're both zeros, so that gives me a 0. This one here, I have 2 the left subtree is the depth is 2 for the left, the right is 1, 2 minus 1, that's a 1. See, that's so the balance factor is a 1. The balance factor for this node here, 0 left subtree, 0 right subtree, that's a 0. Now, the balance factor for the root is going to be, the depth is 3 minus 1, so that's a 2. So definitely this is not a balanced tree. So definitely this root here, this subtree here, or this AVL tree is not balanced. So as you can see, because of the balance of the balance factor. Okay, so this is how you compute the balance factor. Let's look at this root here, at this subtree here. So the left subtree, the right subtree is 0 minus 0 is 0. The left subtree is 1, depth 1. The right subtree is 0, so that's a 1. The left subtree of this node here is 2. The right is 1. The right is 0. The left subtree of this node, so if I put my pointers here, this is 1, 2, 3, and the left is 0, so that's a 3. Now this one here, left subtree is 0, right subtree is 0. Now if I go back to the root, this is the root. So the root has the left subtree is 1, 2, 3, 4. The right subtree is 1. 4 minus 1, that's a 3. So definitely this subtree or this AVL tree is not balanced. So it's not balanced because the balance factor is between, it's 2, 3, and 3. So it has to be, so for the balance for the tree to be balanced, the balance factor has to be 0, between 0, -1, or 1. Anything other than that means the tree is not balanced. So when we build a binary search tree, applying the AVL tree concept, is that while we're building it, we have to do a balancing. Now the other issue when you look at it, why the tree is not balanced. See, the distance level, the distance or the depth between each level to the next level has to be 1. It cannot be greater than 1. In fact, like see this level here, this is level 0, level 1, to the next level, that's 2, 3, so it's more than 1. While if you look at this level 1 here to the next level, so there's only a depth of 1. See, and that's why this is balanced and this is not balanced, because from this level to the next level, there is more than one level, so the depth is more than 1. Same thing here. Look at this one. This is 0. This is level 1. There is 1, 2, so that's why it's not balanced. So AVL trees are very important, and balancing the AVL tree is a very important concept. The word AVL, these are 3 guys that actually came up with this algorithm, and it's their first 3 initials. And thank you, this is on the AVL trees.